Curdy here. Today we're going to talk about finding the area of complex figures. We've already been working on finding the area of rectangles and squares where all we need to do is multiply the length times the width. But there are going to be times where we have a complex figure like this where we can't just multiply length times width. So we're going to talk about how we can decompose that figure to make it into smaller regular figures. Instead of having one complex one, we can actually break it up into smaller rectangles and squares, and that way we can just multiply length times width. So when we look at this figure, we want to kind of analyze it and say, where do we see rectangles or squares? So when I look at this, I notice that if I draw a line right up here, I would have a figure here and a rectangle here. So I'd have two rectangles. I could also draw a line across here to make a long rectangle here and a shorter rectangle there. Either way you do it, you're still going to get the same answer. It'll have the same area. It just becomes a matter of preference. So I'm going to go ahead and draw the line right here to make those two figures. And now in order to find my area, I have to find the length and the width. Now remember, when we do this, the opposite sides are going to be equal, but I want to make sure that I have a full length and a full width. So for example, if I look here and I have a 2 down here, this 2 is only for this segment of the rectangle. It does not give me the full length. So I'm going to have to make sure my sides are for the full length. So this 5 goes straight across, and then I have this 2. But if I look around, I do notice that down here I also have a 3, which if I were able to use my Jedi mind trick and remove this line segment and slide it up, this would fit perfectly here too. And that makes sense because 2 plus 3 gives me that 5, which is my full length. So I can use this 5 right up here, and then I need to find my width, which would be a 1. So in here, my area would just be 5 times 1, which would give me an area of 5 square centimeters. So now I know this area here is 5 square centimeters. When I look at the bottom, I'm going to notice I have a 2 by 3 down here, and this 2 follows this whole length, and this 3 follows this whole length. So to find the area here, I can do 2 times 3, and I can get an area of 6 square centimeters. And then to finish off my problem, I just have to add the two areas together. 5 plus 6 would give me 11. So my full area would be 11 square centimeters. There are going to be times where you have some missing side lengths in here, and it's really important that when you're finding what the side lengths are, you don't just go by looks. For example, in this rectangle, it is not drawn to scale. So this 3 here is gigantic, way bigger than this 3 down here. So never can you say, well, it looks like it's the same size, so I'm going to label it the same. These 2's don't look the same because I didn't draw it to scale. So never go by how they look. Make sure you're able to match up the opposite sides. So for example, here I know that this would be a 5 because the opposite side's here. So if this is a 2, this missing piece here would be a 3. And I also notice that this is a 1, this side is a 1, and that makes sense too because this opposite side would be a 2 here. That 2 plus the 1 does give us that 3. So when you have any missing sides, make sure you go across to match them up. I will be doing another video where we show you how to find missing side lengths if there is a side missing that you need to find the area. So check back for that video as well. I hope this helps, and I'll put up some more of these because this is one of the more complicated topics in Topic 6. So you will find more videos where we practice this skill more. Thanks for watching. Have a great day.